So this is a slightly harder version of the boat problem. Before we had a question where the boat was traveling directly across the river. And now in this one we can see that we have a boat at some start point and it wants to end at some point that's not directly across but across and a bit to the east, it looks like. So a boat whose speed in still water is 2.2 meters per second must cross a 260 meter wide river and arrive at a point 110 meters upstream from where it starts. To do so, the pilot must head the boat at a 45-degree angle upstream. What is the speed of the river's current? So we can actually see if we can draw the picture of the scenario first. So I'm going to start by drawing a little river again. So here's my river. I'm just redrawing what we see right here, but getting rid of some lines that I do not necessarily need. Here's my start. Here's my end. So what we can see here is we want to go from here to here. So this is our resultant, our start to end. We want to go from beginning to end. We also know that the river is going against us. So you know that the facing of our boat, the boat, plus the river vector must sum to this green line I had. So I'm going to start by drawing the river current, something like the following. So I'm going to make it a little more exaggerated so it's easier to see. So what we can see is the heading of our boat plus the river must result in this green line. So in this question we're also given that the angle 45 degrees, so relative to the stream, so I can draw that in right now. This is 45 degrees. Be careful, it's different than just the angle between our green line and red line. So now we kind of have to decipher what's going on. So what we do know is start filling in some values. The speed in still water is 2.2 meters per second. So that's the speed that the boat can travel if there was no river. So it's basically, you look at what direction is the boat facing. The boat is facing in this direction. So this is our 2.20 meters per second. But we actually don't know much of anything else of this triangle. We know this 2.2. We don't know this angle. We don't know this angle. We don't know this angle right here. So it feels like we don't know enough. But we can actually use the distances, that 260 plus 110, to find a little bit more. So let me just draw in another little, draw the river again. And we know this is our resultant from start to finish. But we know that the distance across the river is 260 meters, and the distance upstream is 110. So we can actually find out what this angle is right here. So let's go ahead and find that. So you can see inverse tan. So theta is equal to inverse tan of 110 over 260. So you plug that into your calculator, we get theta is equal to 23 degrees. So you see if that is 23 degrees, and this is 23 right here, and this whole thing is 45, and for that remainder, a small amount right there, must equal to, let's put that in a different color actually. So right here in orange, that must be 22 degrees. So we found a bit more about this triangle. And for any triangle, which hopefully you remember from math class, you need to know these three different pieces of information. But if we know this is 23, we actually also know what this angle is up here. Because the sum of the angles in a triangle must always add up to 180. So if I call this, let's call that phi, you can say phi must equal to the sum of the triangles is 180 degrees. We know in this triangle one of them is 90 degrees, so minus 90 degrees. And we just found 23 degrees. Therefore, what's left over must be 67 degrees. So that is 67 right here. But here's a straight line. This river's edge is a straight line. all the way around a circle is 360. So that straight line, that's half a circle. Half of 360 is 180. 67 has already been used up. So 180 minus 67, that gives us 113 degrees. We've found two angles in a triangle. That means we actually know all three. And some of the triangles, some of the angles in the triangle is 180. So 180, we subtract 22. 180 minus 22 minus 113. We're left with 45 degrees. We don't actually need to do that though, because if we know that's 45 degrees, we actually know it's hard to see sometimes. We have all these overlapping triangles, but see my cursor is tracing this big triangle right here. That's 45, and it's a right angle. If I were to continue this line up right here, 45, 90, that one must also be 45. Now we're ready to go ahead and solve this. So we're saying, what is the speed of the river's current? So we are actually trying to solve for this vector right here. V, water relative to the shore. So we can use the sine law. So you can say V, water relative to the shore. We're just going to solve for the magnitude right there. So using sine law, we need the angle opposite that length. So that is going to be sine 22 degrees. And then we can use any other length and corresponding angle. We only actually know this 2.2, so I'm going to use that 2.2, 0 meters per second. And the angle opposite that 2.2 is that 113 degrees. Sorry. I need to write it as sine 113 degrees. So now we can solve for VWS. So we know what 2.2 divided by sine 113 multiplied by sine 22. We end up with velocity of the water relative to the shore. That is going to be 0.90 meters per second. And we can write down like left, or you can think of it as west, or just need a direction though because it's a vector. And that is our final answer.